Converse of the Pythagorean Theorem. Right off the bat, notice this is a multiple choice, one of the rare ones that individual problems cannot be redone, so I will start off by reminding you how to submit entire assignments if you miss a problem once we open it. First, I'm going to remind you a few things. If you look on the right here, you will see the Pythagorean Theorem that we reviewed last time. If you haven't done that assignment yet, do it first. So you can review that a squared plus b squared equals c squared. Now, what does that mean? That means if we have a right triangle, our legs are non-hypotenuse sides. If we square this one and then add it to that one, we will equal our hypotenuse squared. This is only true for right triangles. Now, this word converse doesn't talk about the shoes. Those are some fly kicks, though. Converses, wow, sounds so old. Instead, in this context, it means basically go backwards. So the Pythagorean theorem, maybe I could just write this out right now, says if we have that right triangle, then we know a squared plus b squared equals c squared. The converse says the opposite. If a squared plus b squared equals c squared, then we know we'll have a right triangle. So today, it's one of the easiest, simplest assignments we'll do all year. You're going to get three numbers. You're going to plug them into a calculator and see, hey, does a squared plus b squared equal c squared? Where I always make sure that c is my largest number. If so, it's true that this is a right triangle. If not, then it's false. Okay? With that, let me show you. So open up your Desmos calculator and the assignment, because I have one more thing to promise you, which is how to submit these. So if you miss one, and I'm not even going to guess true or false because I don't want to risk guessing correctly. Whoops, went back. What you can do is you can hit submit, or you can hit finish attempt down here. So at any time, like say you miss number one, you get a red. You hit finish attempt. And then you hit submit all and finish. Submit. It's going to give you a 0. That's fine, because then you hit this assignment. Again, converse of the Pythagorean theorem. And then now for you, it's going to say attempt quiz now. And you're back. It took, 10 seconds, 20 seconds, but you're back. Okay, so before we used our square root, a squared plus b squared. We're not even going to need the square root for this. Literally, we just need to see if our smallest number squared plus our middle number squared equals our large number squared. Here's how we do this. I'm going to do my first number squared. So 66, reminder that squared is down here. Then I do plus my middle number. Now remember to use your numbers, not mine. I get 12,100. So separately, I'm going to see what is my largest number squared. So I've got my a squared plus b squared up here. And then separately down here, I have got my c squared. If these two numbers and boxes here perfectly match, it's true. It's a right triangle. Or it's what's known as a Pythagorean triple. Pythagorean triple just simply means a situation where a squared plus b squared equals c squared. All right? It does both of them. But if your numbers do not match, like these aren't the same number, not even close, and if they're off by even one, then it's false. These aren't the same. And then check it out. When you leave this calculator up, you can do what I love to do. Replace these numbers. Now I've got 88 squared plus 105 squared. Now I compare that to my largest, which in this case is 137. Oh, look. These do perfectly match 18,769. They do. It's true. The assignment is that fast. It's that simple. That's all it takes to see if you have a Pythagorean triple or a right triangle. Now we have a situation where they want to know right triangle. So it's the same thing. I just got to make sure that my 149, my hypotenuse C, is in the C spot, in the largest by itself. And then the other two, I can put in any order. So I've got 51 and 140. And look, these numbers perfectly match. So it's true. If this did not make sense still, rewind, watch the explanation, because I'm going to leave you to do the rest of these. because they're all the same. I guess the point will be is if you have decimals, same thing. So I'm going to put in 36.0 squared and 214.5 squared and compare that to 217.5 squared. And look, they match. All right, I'm just going to make sure there's nothing weird at the end of this assignment. Same thing if you have decimals, if you have a picture. You can do this for all 12 problems. Okay, decimals. And then a couple pictures at the end. Okay, this is the rarest of rare, where I am not going to submit this with 100% because I want you to get practice on all of these. Meaning, I'm going to leave it here. The important thing to keep in mind, just make sure your largest number is squared by itself. Add your two smaller numbers together squared, and compare. If you somehow miss one, that's the other thing. These are true or false, okay? So if you miss one and you restart an assignment, you got a 50-50 chance no matter what. It's so student-friendly. It's so easy relative to other complicated ones like the quadratic formula where you're typing in this long thing, and if you're off by even a digit, the whole thing's wrong. So good luck. I believe in you out there. You got this. In fact, as I'm talking about this, maybe you're already done because you just used the same formula to do all 12 problems. If so, go you. As always, this has been Class Away from Class with your digital teacher, Dylan, wishing you the best every day, week, month, and year of your life. Peace out, bean sprouts, as one of my good colleagues says.